manufacturing work and work in other industries is really beginning to shift from people doing physical tasks close to where a product is being made to people supervising a process, really working in a more control room environment where they're orchestrating machines.
Hello, everybody. Welcome to MIT Learn. You're listening to Why This Matters, a podcast that aims to connect abstract ideas with real-world impacts. I'm your host, Daniel Braconnier. Today in the studio, we have Dr. Ben Armstrong, the Executive Director of the Industrial Performance Center here at MIT. And together, we're going to find out why this matters. But before we get to this, thanks for being here.
Thank you. Thanks for having me.
Tell me about your role here a little bit more at MIT. What's this Industrial Performance Center?
The Industrial Performance Center was founded by a multidisciplinary group of faculty in the late 1980s, early 1990s. It came out of an MIT-wide commission on productivity. And the goal of that commission, which was formed by then MIT president, was to understand how American manufacturing can compete with the rise of Japanese manufacturing and other manufacturing in other countries that were really eating the Americans' lunch at that point. And a number of MIT faculty thought this is a really important issue for us to understand and that we have something to contribute as scientists, engineers, social scientists. And what they ended up doing is coming together to study the issue from a number of different angles. Was there a technological problem that was facing U.S. manufacturing that led it to fall behind? Was there a workforce problem? Was there something in the capital markets that was really troubling U.S. manufacturing? Mm-hmm. And their conclusions they summarized in a book called Made in America, which essentially laid out a course for how U.S. manufacturing might have been rebuilt in the 1990s. And unfortunately, a lot of the great ideas in that book didn't come to pass, and U.S. manufacturing continued to decline after that point, and the decline actually got worse. It accelerated in the early 2000s. But nonetheless, the Industrial Performance Center came out of that project, and over the past 35 years, we've been doing similar research, like the research that started the center, research on manufacturing competitiveness, globalization, how automation affects the workforce. And our core has always been really heavy industries like automotive manufacturing, aerospace manufacturing, metals manufacturing. But we've branched out a bit. Some of our research now focuses on logistics. We have projects in generative AI that cut across industries, looking at how generative AI is reshaping work. So our scope's expanded somewhat, but the core pillar of our work has long been manufacturing.
I mean, really important. So were you a part of the creation of this, or how did you end up becoming the director?
Well, I was in diapers when the creation was happening.
Yeah.
So no. But when I was, I started my career in Silicon Valley. I was graduating college at a time when the tech industry was really on a meteoric rise, and the most exciting job I thought, and my peers thought, was at places like Google, where I went to work first and really tried to understand, well, how is this company running? What's so exciting about this company? Of course, you see the rainbow-colored bean bags and the ping pong tables in the offices, and I was curious what was happening, and I went. And I learned a lot, but I also learned that wasn't for me. That wasn't the business environment for me. It wasn't where I felt like I was really making a contribution or really feeling satisfied with the work that I was doing. So I moved on to a startup. And when I was at the startup, I started working on a project that was trying to build something physical. Of course, at the time in the early 2010s, every company that I could see in Silicon Valley was building something digital. It was focused on software. The costs were very low. There was a lot of venture capital for new software ideas, mobile apps, software as a service, but not many people were building anything physical. And I came from the Midwest, growing up around the automotive industry, and I really liked the idea of building physical things that could be sold for some real measurable margin. And I and some peers wanted to build this physical thing, and we realized it was really hard to build it in the US. It was an electronic device with some remote sensing capability, and everyone was telling us, you just got to go build it in China. You got to find someone who can set you up with essentially a supply chain in Shenzhen. That's the way you build it. And it got me interested. So why is it so hard to build something so basic that felt like so basic and so essential to the modern world, like an electronic device in the U.S. And that led me to come to MIT and start studying this problem of what really happened to American manufacturing. And as a graduate student at MIT, I started getting involved in the Industrial Performance Center, where I am now.
Yeah, there it is. So you mentioned you grew up in the Midwest. Was your family connected to manufacturing at all, or how did you kind of have that perspective from being out there?
Well, in two ways. The city where I was born had a manufacturing legacy in the automotive industry. It was a city that really grew with the rise of manufacturing in the Midwest around Chicago. And by the time that I was growing up, it was nowhere to be found, right? There was a casino downtown. There wasn't really any factory jobs or middle class jobs where you could support a family like the lore of the post-war 1950s and 60s. So manufacturing had gone, but it was sort of in the legend of the place. So a lot of deindustrialized towns like that around where I grew up. And then the second piece was that my dad was in the automotive industry and was in sort of this constellation of suppliers and distributors at the lower tier below the OEMs. So what he did was he sold a number of different automotive components to lower volume customers like John Deere or Caterpillar, but it was the same kind of components that would go into Ford or GM. So I had a vague sense growing up of, what these parts looked like and what a warehouse floor looked like, and also what the ecosystem was. It wasn't just the Fords and the GMs. There were hundreds, if not thousands, of other companies that were really important that fed this whole ecosystem that was a critical part of the economy. And that those small companies, like the one where my dad worked, was just as important as the large companies that made the headlines.
Do you feel like that experience got you into science and engineering, or was it some other thing that sparked that interest?
Well, I think like many kids, what your parents are involved with, you want to run away from before you run back to.
Sure,
so
yeah.
I think maybe going into Silicon Valley from the Midwest is like trying to understand if the grass is really greener elsewhere. And then I'm very glad that I sort of came back home, at least if not geographically, certainly in the subject matter, that I do feel connected to manufacturing in a lot of ways, and I'm happy to go back and discuss the issues I work on with my family, who know more about them in many ways than I do.
Awesome. Our listeners will probably guess that we're talking around or about manufacturing today. So before we get into more topical questions, in your mind, what is manufacturing?
So the traditional definition of manufacturing is anything to add value to a physical good by somehow transforming it, right? So I'm butchering the textbook definition, but really there is a process in which you take certain materials and components and turn them into something that's more valuable. It's almost like a biological process where in our bodies we constantly have different kind of biological components that are coming together to do something that those individual components couldn't do on their own. And that's a lot of what manufacturing is about. It's about reshaping metal and plastic and composite into something that then can go into something else that can go into something else that then becomes valuable to individuals and to society and to industry. One of the I think why I'm hesitating is that I've begun to think about manufacturing even more broadly than the traditional sense of steel mills and car factories and plane assembly and toy making. And I'm thinking about it in two ways. One is I think we are more and more looking at mining and the cultivation of raw materials as a critical part of manufacturing, that actually taking things out of the earth and making them more valuable follows a very similar process, requires similar technologies as traditional manufacturing. And to think about them holistically makes a lot of sense, that the mining upstream of core materials and the processing of them. And some mining companies are vertically integrated, such that they do mining and manufacturing and are thinking about that as hand in glove. And then the second piece, which is important, not just because it's technically very interesting, but also because it's environmentally important, is this process of remanufacturing. Sometimes it's thought of as maintenance, repair, and overhaul. So in the automotive sector, in consumer products, in aerospace in particular, there is a big industry in taking existing components that are worn or torn or
Sure.
twisted and making them usable again. And that I've begun to study that with a colleague, Zach Cordero here, who's in the Aeroastro department, and understanding how new technologies might make that process, the process of remanufacturing, more efficient. Because you can imagine to set up an automated line for a car that's going to look the same every time and control that line. It's a feat of engineering, but automation works really well when you're doing the same thing over and over and over again. But what if the part that you're making or the part that you're assembling is slightly different every time, and you can't predict exactly how it's different? That it requires not just the traditional automation technology, but a software layer on top of it that might need to help the machines adapt to slightly different environments. And that's a really exciting technical problem with great potential benefits if we're able to reuse materials that we would have otherwise scrapped.
Oh, yeah. So this is different than recycling, I guess. Or would the terms be interchangeable in the sphere?
Well, recycling is quite different in the sense that when you're recycling something, like let's take what Redwood Materials does with a battery, there would be a difference between recycling, which is extracting the valuable raw material from an object and then using that raw material in a new manufacturing process. What MRO facilities do in aerospace, for example, is they might take an engine that's been on a plane working for a long time that is, warped or needs an overhaul, and they'll make it as good as new, effectively. Or they'll take components and they'll run them through a new machine process or turbine blades and run them through a new process to make them as good as new so that you don't need to necessarily fab a new blade. This is a long-standing set of processes, but at least my hypothesis is, and we're still figuring this out, and there's some folks in Germany, actually, at the Karlsruhe Institute of Technology, who are doing great work in this area. They have what they call the circular factory, where they're taking all sorts of different components and equipment, and they're trying to design processes to take these used components and bring them back as good as new in domains where this hasn't necessarily been done historically, like in aerospace.
So with that, you were mentioning automation. Do you feel like that's the kind of the special next step to make this remanufacturing possible? Or is a lot of it still very hands-on?
Well, I think the starting point is certainly hands-on, because you could have someone with a lot of craft-based skills go in and kind of remachine and tweak a piece to make it work. I mean, this is the traditional hobbyist who might be able to make a used lawnmower, add a few new components and then make it hum better than ever. Those sorts of skills certainly exist. The only issue is that's not more cost-effective necessarily than adding more capacity to an original production line. So the economics of it are really the challenge of how do you make this remanufacturing or the circular economy essentially have more economic return than the original manufacturing economy. And it's not going to be true for all components. For example, cheap replaceable components, it might not make sense to repair those. But there are enough high-value components, and this is what folks in Europe, where there's a higher cost of carbon and more interest in sustainability, they're banking on, if you do raise the cost of carbon, for example, which is more intensive in original manufacturing, you then bring in, it becomes a lot more attractive to invest in remanufacturing in more domains.
Yeah, that gets to, I guess, industrial policies across the world. I know you've done a lot with U.S. focused stuff, especially here in the center here at MIT. How do you feel the connection of, because in industrial policy can feel pretty like up above everybody that might be just working in like a metal shop bending some sheet metal or something, but how do you feel it connects down to the local economies around here?
Well, the main goal of industrial policy, if we can have one kind of unifying goal, is to shift the structure, industrial structure of the economy, to make to give some industries more advantage and some industries less advantage, oftentimes. So industrial policy historically has been either to incentivize innovation in new industries and make those new industries more attractive so people go into those industries with the idea that they maybe pay higher wages or are more competitive. And over the last 4 administrations, really, the Obama administration, Trump 1, Biden, and now the current Trump administration, there's been a concerted effort through a variety of tools, different tools for each administration, actually, to incentivize the revitalization of American manufacturing. And those policies have been based on a few simple ideas. One is that what we learned between 2000 and 2010 was that the costs of losing manufacturing are pretty dire. When you let go of manufacturing, you lose a lot of middle-class jobs. You really hurt certain communities pretty sharply. You make it harder for our national security apparatus to maintain its technological advantage and advantage in warfighting material. And then finally, you lose your ability to innovate on the technological frontier, because if you're building, the next generation drones, or if you're building the next sort of electronic device, and you're designing it in the U.S., but then you have to go and build it and really figure out how to iterate in another place, you lose some of the capacity to really scale the business in the United States. And we've seen more and more that businesses that started with the design in America and build in Asia strategy just ended up being businesses that were scaling more dramatically in Asia. So that recognition led the U.S. to try to claw back some manufacturing activity, not necessarily taking supply chains that were already established in Asia around, let's say, garments, shoes, even electronics, and then like reshore them totally. There's been some talk about that, but that's really hard. I think the goal, primarily, and what I see as the goal, is to ensure that when there are the next wave of physical things that need to be built, the most advanced physical things that need to be built, that we have the capability to build them and to compete to build them effectively in the United States. And that's what the goal of industrial policy has been. How does that matter for American workers, American factories? It hopefully will make it easier for them to access knowledge to do their job better. Sure. It will give more incentives for them to attract very skilled workers, because manufacturing jobs will be more attractive if these policies are effective. And it will hopefully, and this is, I think, a more controversial point, is it will make the raw materials, the materials necessary to do manufacturing, equipment, infrastructure, other technology, more accessible to them. And that's one of the real disadvantages that American manufacturers have today, is that equipment costs a ton. It takes a long time to access, and you don't necessarily have the skilled workforce to operate effectively. Sure, yeah. And in manufacturing hubs, like I was just in southern China, it's a totally different story, right? The equipment is highly affordable, it's accessible everywhere, and that allows you to move much faster and at a much lower cost.
You brought up two things that seem interesting, like I guess the societal view of manufacturing as a career in the U.S., at least from what I know, seems a little lacking. Like there's a huge gap between a workforce age of new people coming in out of, say, college or high school, and then you get the really trained individuals who are doing time during their retirement at some places. Whereas, and you bring up over in Asia, it seems like that's almost just a normal, like it's just, oh yeah, I can totally do that if I wanted to do that. And where do you see the big differences and why we're kind of there? I know there's a lot of outsourcing, but what else do you think is affecting that?
It's a long story. Not that I need to spend a lot of time, but It's been happening for a long time. Yeah. So this isn't something that just came up since COVID, where there was a big labor shortage and a lot of focus on, why aren't people going to the trades? Why aren't people going to manufacturing? But this is a story really that started in the 1980s and 1990s. So we've had now, at least a generation and a half of people who didn't look at manufacturing jobs as attractive. And one of the reasons was that you looked at this industry and it had declined from being 25% of the economy or 25% of the workforce to 10% of the workforce. Like, am I really going to go into an industry where it looks like the bottom's falling out and factories are closing and maybe my parents' friends who were in the industry lost their jobs? I don't think as a parent I would want to send my kids into that
Sure, yeah.
industry. And you don't really want to get on a sinking ship, I think is how a lot of people felt about the time. So what you saw as a result was the workforce in manufacturing became progressively older because people stuck around in an industry that they liked, that I think for a lot of people is very satisfying to
Mm-hmm.
build things and to see the fruits of your labor going out the door. But they weren't backfilling those workers as they were retiring with new skilled workers. That manufacturing is essentially a last resort for a lot of people. And I think there are a few other things that were happening during that time. One is that manufacturing went from being the best possible job wage-wise for someone without a college degree to being a job equivalent to a lot of jobs in retail or logistics. So in 1960, if you're a manufacturing worker without a college degree, you're on average earning 40% more on a factory floor than you would earn in an alternative career. Today, you earn about 2% more on a factory floor than an alternative career. In Massachusetts, you earn less. You could earn more at a lot of other places like an Amazon or a Walmart or Target, maybe not Walmart. So anyway, so this is a big transformation that manufacturing went from this high wage, really, I think, respected career to being a career that's lumped into a lot of other, low wage work that's specialized for people without a college degree. So I think there's both a rational decision from young individuals who say, I don't want to go into an industry that's declining. I don't want to go into a job that's comparatively low wage that also requires me to invest in skills, whereas I might be able to just jump into another career on the job and figure it out. I think there's something, though, that young people entering the workforce are missing, which is the opportunities for upward mobility in manufacturing, the ability to gain new skills. And one thing that we have in the U.S., and it manifests other places as well, like Germany or Japan or China, is that people who really invest in developing skills in manufacturing can earn a great career and can really rise into positions that they're considered engineers, even though they don't have a college degree. There's a big share of folks in manufacturing who have engineering titles but don't have a 4-year degree, and they earn really good wages that are far higher than they can earn in other domains. So the good jobs in manufacturing still exist. They're just hard to find, and they're might take more work, particularly for people without a 4-year degree. So that's the challenge, where essentially it's the door to those good jobs is hard to open, but it's still there. And I think the goal for policymakers, for I think institutions like MIT that work with employers and help with training, is just to make that door to good jobs in manufacturing easier to open and maybe a little wider so more people can fit through.
Do you feel like that door is opening?
I don't think we have the evidence. I mean, I was quite optimistic after COVID. So we had a pretty bad labor market situation in the around 2018 before COVID. So there was a shortage. There was far more job openings in manufacturing than there were people who wanted those jobs. So you talk to most manufacturers, like, I can't find people to hire. I want to grow. My customers want me to grow. I just can't find the people to do the work. That got astronomically worse, triple the job openings after COVID, right, 2021. But what we have in 2021 is really a mobilization of private sector capital and public officials that saw COVID and said, oh no, we can't let this happen again. We really need to support a new workforce agenda and new factory infrastructure in the US. So not only job openings triple, the investment in new factories, tripled as well and really coincided. So there's this real energy behind the growth of manufacturing, and I think an excitement around manufacturing jobs at places like, new battery factories making electric vehicles, or places like TSMC in Arizona, which were different kinds of jobs and people had associated with manufacturing. And unfortunately, beginning in 2025, we saw what had been growth in manufacturing investment and growth in manufacturing employment really taper off. And last year was a year of manufacturing decline for the first time in quite a while, really accepting that, like the COVID spikes and troughs. So I'm still optimistic that there's still a consensus that we need more manufacturing in the U.S. And I think this short-term decline will give way to longer-term growth, and we'll begin to figure out these workforce issues. But we have a long way to go.
So I guess thinking back to wanting to try out Google, and that might have felt like the cutting edge at the time for a lot of people, like getting into CS jobs or more software oriented type of things. What do you feel the cutting edge of manufacturing is nowadays that would be an exciting, enticing thing for people to get into that line of work?
Yeah, and just to clarify, I'm not an engineer, so
Yeah.
I was not going to Google with that. Maybe I would have liked Google a lot
Yeah.
more because it was interesting. There's this hierarchy where the engineers are royalty at a company like that, and the rest of the people are really kind of figuring out their own roles and identities. And in manufacturing, you have some companies that are similar, where you have certain kind of classes of workers that are really given a lot of authority and creative license, and then factory floor workers are often in at least American companies. I don't want to generalize because there are a lot of great American companies that give a lot of discretion to factory workers, but one of the big differences between, let's say, a Germany or Japan and the U.S. is the level of creativity, discretion, respect given to the workers on the factory floor that I think that American factories in general have a lot to learn from. What is the American factory job? I think two answers to this. One is, geographically, we're in a bit of a pickle with American manufacturing. It used to be very clear where the hub for manufacturing was. It was along the Great Lakes in places like Cleveland and Detroit and Pittsburgh. Today, if an MIT graduate wants to go into manufacturing, there's no clear American region to send them to, right? Maybe if they have a very specialized industry, we can send them somewhere. But if we're really being honest with ourselves, we would probably send them to Shenzhen in China to figure things out and to really learn and work for a fast-paced company that would satisfy their interests. I think that needs to change. I think we need to figure out in the U.S. where is going to be the hub for the most exciting, creative, talented people in manufacturing to go, to build companies, to help other companies grow. Our American version of what Detroit was in the early 20th century. And that's missing today, frankly. The closest thing we have to it is in Southern California with startups coming out of SpaceX and Tesla. And I think in Southern California, you have companies like Anduril and SpaceX and a number of new investors, mostly related to the defense industry, but a lot of really exciting companies. And despite being a very high-wage labor market, there's been a bounty of really great manufacturing activity there and excitement about learning how to make things. I was surprised when I went to visit a startup in that region, and they were doing work with composites, and they were doing some complicated welding work. And I asked, because I assumed, given this region, that they were going to face labor shortages and have a hard time finding those people. And they said, well, they're expensive, but we have a lot of them in this region because of the excitement for people to work in these sorts of places that are bringing a little bit of this Silicon Valley fairy dust. We're building companies that are going to change the world, except in hardware. And that appeals to a wider skill set than just computer science, core 6 majors at MIT. So I think if there is a region, even though it's quite a narrow set of industry, it would be Southern California. If there are a set of companies, the real paradigm shifters were Tesla and SpaceX. Those companies have lost some of their luster, I think, for a variety of reasons. But there is a family of companies now that have been founded by Tesla and SpaceX alums that just think about manufacturing and hardware differently than legacy companies like let's say a Ford or a General Electric, and that I think are exciting to recent graduates.
So what are the ways in which they think differently about manufacturing?
So there are 3. And I don't think this just comes from Elon Musk and the maybe you think of like the Walter Isaacson deification of his ideas. I think it comes from the types of people who came together to build those companies, people who have backgrounds in the hard sciences, who have backgrounds in the Tesla case, in semiconductor manufacturing as well as in automotive manufacturing. And what they really do 3 things. One is they're willing to move much faster than peer companies. So the way that Tesla ended up being more productive than their peers wasn't to build a new kind of assembly line that moved much faster. It was instead to have much shorter product cycles so that when other companies were spending a lot of labor hours developing and iterating on the next version of the car, Tesla was already done and they were into production. So they can afford to make more mistakes in production with a much tighter product cycle. The second is not being afraid to make mistakes, right? Where
Mm-hmm.
Tesla was willing to change various elements of the vehicle on the fly as they were figuring out how to improve it. The design, it wasn't locked in the same sense. And I think part of this was because they were so early as a company, they had to be willing to make those mistakes. But this was really importing some of the software company philosophy of failing fast and adapting.
Mm-hmm.
That it was, I think, very exciting and ended up working in their ability to learn a lot from the Roadster and then learn a lot from the Model S and so on until they get to the Model Y and they have the best-selling vehicle. Right. So that was very rapid iteration. And for a startup to achieve that in such a short period of time, I think is really remarkable. And then finally, I think the investment in software. So Tesla and now Rivian and some other companies have really restructured what the manufacturing workforce looks like for their respective industries. And that's with a much larger investment in software capabilities. So they can build internal custom software tools.
Mm-hmm.
They can use the data that their machines are throwing off much more effectively. And they can be more flexible, which is really what the superpower that software brings to manufacturing is flexibility. And for a lot of other, even large manufacturing companies that don't have these capable, I mean, they have internal software teams, but they
Sure.
rely a lot on external expertise and external vendors. They don't necessarily get the same flexibility out of their software.
So with the software, that I'm sure a merger that's a lot of automated and maybe some robotic stuff on the line. With automation, I know that's a big thing with when people think about manufacturing nowadays. Is are we entering a space where we kind of know where that fits along with someone who's actually on the shop floor, or how is that changing? That position changing?
It varies a lot, product to product, industry
Yeah.
to industry. So there are certain things that we've really figured out how to automate. So producing certain motors,
Mm-hmm.
welding the body of a vehicle. There are extremely impressive automated lines and systems that we're really, that manufacturers are great at, and that there's very little human intervention. There's human supervision. So there's a control room with people figuring out how to adjust. And part of the challenge is when something goes wrong, how do you minimize the downtime of that automated system? And then there are other operations, particularly final assembly of finicky devices, where there are different angles where you have to screw things in and the pieces are delicate or flexible. Those are really hard, and there is a lot of manual labor that remains.
Mm-hmm.
But most processes are somewhere in between, where you have a lot of human labor and maybe some capability to automate, and it's maybe a borderline call of whether the automation is worth the sweat that would go into it. And one of the difficulties for American manufacturers is that automation isn't just the cost of the robot or the equipment. It's often the cost of the knowledge to figure out how this robot plugs in.
Absolutely.
And that's more costly. Some of my colleagues have estimated 2 to 3 times more costly is the integration of the automation and the automation itself. Now, where we're at a disadvantage in the United States is that that knowledge is harder to come by than in other places with a lot more density of manufacturing. So if you go to a factory in a place with tons of manufacturing capability, you'll have automation engineers who do this all the time.
Mm-hmm.
They know integration, they can do it faster, and they're already on staff. So it's not necessarily an additional cost. You're kind of expecting to do that integration. Whereas in the US, a lot of companies, they rely on a third party to do it, and you need to set that up, and maybe you need to wait for the equipment because the equipment's coming from overseas. So the whole process of doing automation becomes a lot more complicated, a lot more costly, and there are just plenty of reasons to say, no, I'm going to do it how I know how to do it. So we end up with what we have today, which is only about 12% of American factories with any robotic automation at all. A lot of them have specialized equipment. They know how to automate in the ways that are industry standard, but pushing the envelope, really making dramatic improvements has been quite hard for companies. Automotive industry, like you asked about Tesla, very different story. About 50% of all robots in deployment are in automotive, and a lot of the big automotive processes are quite automated. I would say Tesla's advantage doesn't necessarily come from more automation. It comes from more vertical integration, where Tesla was willing to make more parts of the car that they thought they could make and control the quality of better, rather than rely on suppliers that might have variable quality issues, or they might not be able to might not be able to move as fast as Tesla was moving and changing.
Yeah, I've toured some facilities around in the Cambridge area, and I remember one from a sheet metal bending plant. They had this. It was from maybe 100-year-old, just like 500-ton press, and that was their workhorse. Every other machine was either just as old or maybe a little younger, but pretty much just classic huge cast iron machines that no sense of automation over there. They had maybe forgive if I forget the acronym, but is it a DRO that controls location on a mill?
Oh, you're talking about like probing?
Yeah.
Like they had automated probing to look
Yeah,
at.
they had that on like one machine out of all of their stuff that they did, and everything was manual. And so you mentioned like Tesla does all the vertical integration of their parts and everything. Do you think the pressure of automation kind of being the next step for a lot of manufacturers, is that founded, or is there really still a place for, like, just because the machines are old, but if the product's still good, is there a way to make that work?
Yeah, I mean the only way that manufacturers in the U.S. with far higher wages and other costs than manufacturers elsewhere can compete is by becoming far more productive.
Mm-hmm.
A few ways to become more productive. One is to invest in technology that helps you do the same kind of thing faster than you could do it otherwise. The second is to invest in skills where the people figure out how to do things faster and faster.
Sure.
And then the magic is when you can do both, right? Have more skilled people working with better technology. So we talk about automation, and I think most people's minds go directly to robots that are, a physical arm doing something a human arm might have done. But that's not the only kind of automation, not by far. There could be automated inspection that uses vision systems, which is becoming more and more popular in manufacturing. There could be software that helps do changeovers where people don't need to reprogram, manually a system. So there are all sorts of different technologies that what they're trying to do is help a human do a task faster. The human in manufacturing, the human is always in the loop in one way or another. And the question is, can you help them do more tasks faster? So I think in the long term, and this is what I was teaching a class in the fall that was on this theme, is manufacturing work and work in other industries is really beginning to shift. It's a slow shift, but it's beginning to shift from people doing physical tasks close to where a product is being made to people supervising a process, really working in a more control room environment where they're orchestrating machines. And they're trying to ensure that the machines are doing what they need to do, and they're adjusting them as appropriate and trying to make them more flexible. And that control room environment is in some ways more the work of a traditional engineer, but it also requires some in situ experience. You need to know what it looks like when a process is going well on the factory floor, and you need to know all the different varieties of how it might break down so you can respond quickly. So there's this mix of knowledge that's really required. But I think that the goal for a lot of places is to make that shift from lots of workers close to a process who need to be hands-on to probably a smaller number of workers per value add, right? Maybe I imagine as manufacturing grows, more workers overall, but each worker is going to be responsible for a lot more value that's created in the factory.
I think that really clears up a lot of stuff when people are thinking about automation in manufacturing. Is there any other like misconception that you think people would need a little bit more information?
Well, I think there's competing narratives what manufacturing is. And part of it's because there's high variety in factories that you might have seen in your visits, and that my colleagues and I have certainly seen when we go out and visit factories, is that there are some factories that are really focused on quality and reliability, in the sense that a successful day is to produce exact copies of a thing many, 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 many times and to hit a target. And you could think of this as some people call it, copy exactly manufacturing, or like set it and forget it manufacturing. And that's important. It's important to know how to produce something extremely reliably with very little variation many times over. But that set of skills is insufficient for the US to compete in manufacturing. There's this other type of manufacturing, which is the type that we talked about with Tesla, which is much more inventive, where you're trying to figure out how to produce something and produce it slightly better over time, and that you're very flexible to introduce new varieties of the product and produce the product in new ways, and maintain reliability so that you're still within spec, but that you're really changing the process over time. It's not a copy exactly type of manufacturing. And that second type is prone to a lot more error and requires a lot more I would say controls in other ways, not the traditional like controls engineering. But that type of manufacturing is going to be required if the U.S. is going to be prepared to make new things and figure out how to make new things quickly. It's really that manufacturing is focused on learning in a way that's different from the copy exactly manufacturing. Now, I'm sure that comment will have some pushback from folks in this maybe that feel part of the copy exactly camp, because I'm not trying to devalue that type of manufacturing at all, because there's a variant of that kind of manufacturing focused on continuous improvement. One of the big mantras among U.S. manufacturers has been lean, which is a philosophy that came from the Toyota production system and is roughly described as continuous improvement through respect for people. And you can have something that you need to make 1 million times in exactly the same way and run a continuous improvement process on that product to find to cut out steps and cut out waste, and give people more discretion of finding ways to make that product exactly the same, but more efficiently. I think that's great. And that would be a way of doing the copy exactly model better. But there still needs to be the ability to learn how to do new things quickly and be comfortable with high levels of variation, I think, if we're going to compete with some of the very powerful and impressive manufacturers elsewhere in the world.
Yeah, that makes a lot of sense. All right, well, so we're nearing the end. I'm trying to start this TLDL segment, so too long, didn't listen. And if you could address our camera over here to our listeners and maybe give a quick summary about, why what we talked about today matters and what you're looking forward to in this type of area.
Well, if you care about building new kinds of products like drones or the next generation of vertical takeoff and landing aircraft or nuclear energy, all of those new products rely on us figuring out how to manufacture new things in new ways competitively. And that's why we should care about getting better at manufacturing.
Thanks again for joining us, man.
Thanks so much. Appreciate it.
For all our listeners still curious, which I'm sure some of you are, you can learn more about manufacturing and a whole lot more for free at learn.mit.edu. I would recommend, if you're a junior level undergrad and curious about manufacturing, there's the course number 2008X, Fundamentals of Manufacturing Processes, is a great course to get started online with that. And this has been the MIT Learn podcast, Why This Matters. I've been Daniel Braconnier. Thanks for listening.